Okay, so here is the second installment of the how to use Excel to make high quality graphs. And we have one more data set to talk about before I start talking specifically about the kind of graphs that you all should make for your flower food experiment. So this is data set 4, as you can see here. And I have one group, which is group A, and this is a set of pigs that eat grass only. And then we have a group B that is fed slop. And notice here that I have data for the mass of each of these pigs underneath each one of these groupings. There's no particular order to these. It's not like they were paired up, so this pig wasn't necessarily paired up with this pig, nor was this one with this one. These are just randomly thrown in here. Okay, so we have, imagine if the question was something along the lines of, which pigs get fatter faster? Those that are fed grass or those that are fed slop? And this would be a question. You would have this then as a couple of experimental groups. Maybe you can consider one to be the experimental group, the other to can be the control group, whatever. And this is the data you came up with. So you need to then figure out whether or not it makes sense to feed them grass or slop if your goal is to make them as fat and juicy as possible before you sell them to the butcher. So if that's the case, um, you might think, okay, well, let's go ahead and graph it the same way we just graphed dataset 3, which was from the previous video of Mr. D's ice cream. And if we did that, let's go ahead and collect all this stuff. And then you would go up to Insert, and you would go to Scatter, and then this is what it would look like. Now, here's the thing when you do a scatter plot that doesn't have a clear X set of values or independent set of data, which is that it takes the first of the pieces of data and it simply assigns that the value of 1, and it takes the last and assigns that the value of 8. So in fact, if we take this for a moment and move this to the side so you can see, 345 pounds corresponds to this data point right here, 255 to this data point here. But don't forget what I just said moments ago, which is that I don't really, these are in a random order. It's not like this was the first pig, second pig, third pig, fourth pig. Yes, it was in terms of the order in which they happen to appear in this data set, but there was nothing special about this pig that made it number 1 and this one, say, number 8. They weren't ranked in any sort of way. So then you might say to yourself, well, then we should rank order them. We should do it from the largest pig to the smallest pig. And yet again, if we did that, that's fine and all, but there's no reason why we need to do that. Remember, the question is about which is going to produce the fattest pig, grass-fed or slop-fed, and whether you put them into an order so that it has a nice gradual slope, downward slope or upward slope really isn't going to change your question or be able to change the answer to your question. But let's leave it like it is right now because it's kind of an interesting thing to talk about. And let's do what we were proposing to do as we did with Mr. D's ice cream. Let's go ahead and put in this data set on the exact same set of axes. So do you remember how to do that? Click on the graph here, go to data. There, I don't know why it didn't exist there. And then hit chart add data. I'm going to then collect up this, lift off, put it in, and boom, hit OK. And now you can see that this is 408, which corresponds to the 408 here. This is the second one here is 354, corresponding to the second pig, etc. And again, there was no reason why these ones are in any particular order because it was randomly sorted. So you may look at this and say to yourself, well, in this case, 1, 2, 3, 4, 5, 6, it's sort of 6, it's hard to say because they're both right on top of each other. 7, 8, oh, it looks like all 8 of the red ones are above all 8 of the blue ones. And while it is true that is the case, it's a lot harder to see than if you could simplify this somehow to show that the group A they were smaller pigs on average than group B. So what would you do? Well, similar to like what we did over here with dataset 2, where we had to create a statistic, and that was a frequency, the number of times it existed. We wouldn't want to do that here, but there is something you can do, which is to generate an average. Now let me show you a quick shortcut on how to do this if you're working with Excel. If you go to a cell that's just below all your data here, and then go up to this symbol up here which says auto sum, but don't click it. Go to this down arrow and you'll see that there's average that you can select. So select that, and when you do so, you can see that it has selected all the numbers above that. And if it's, as long as it's selected all the numbers above that and all is good, then just simply hit return. Boom. And there you have the, oh, I didn't mean that. There you go. There you have the average mass for all 8 pigs in group A. Now, you can do the exact same thing with group B. You can go up, you can hit auto sum. However, here's another trick. Instead of doing all that, you go over to this value, which has the formula that you can see right here, and you grab this little corner block here, and you drag it over until it highlights the adjacent block to it, and then lift off. And lo and behold, that also calculates the average for that column of data. And you can confirm that by clicking on it. And you can see here it averaged all the data from P6, which is this cell right here, all the way to P13, which is this cell right here. So there we have 2 pieces of data, okay? Group A and Group B pieces of data. Now, this is potentially sort of useful, but it's not going to be as useful as what you'll see I'm going to create next. So in this case, we're going to break free from our need to use a scatter plot because you only really have 2 pieces of data now. You have this datum, which is 294.75 for Group A, and this datum for Group B of 405.25. Okay, so doing a scatter plot would be a little odd because it would just be 2 points on a set of axes. So what we're going to do is, rather than do a scatter plot, we are going to create a bar graph to show this. To make this easy on us, however, I'm going to take these 2 pieces of data and I'm going to move them down to about right here. And then above this, for this first one, I'm going to write grass-fed. And for the second, I'm going to write slop fed. And then I'm going to highlight both these. I'm going to go to Insert. I'm going to go to the column graph or bar graph. Notice that I selected the stacked column. I could easily have taken any of them, frankly. And you'll see that the beauty of this is that because I put in grass-fed and slop-fed up here, it automatically labels them as grass-fed and slop-fed. Had I not done that, you would have simply seen a number 1 and a number 2 here, which is what Excel sort of imposes on graphs if you don't provide the categorical variable here on the bottom. But look how great this is, because it very clearly shows that slop-fed is a better option if you want to have fat pigs versus grass-fed pigs. And don't forget, when we go back and think about what this looked like when we tried to do it as a scatter plot, where yes, you could get that trend because you could see that all the slop-fed dots were above those that were grass-fed. This is much more powerful because in a very simple way, and really being simple is good because it makes it more clear. In a simple and powerful way, it shows that slop-fed is better at fattening up the pigs than being grass-fed. So think about that, you guys, as you go to make these graphs for yourself. It doesn't have to be complex. It has to be simple. For some reason, Choate students always think complex means better. You're nuts to think it's better when it comes to a graph. All right, so now that we know how to use Excel to make graphs, let's shift our attention to what you're going to do with your actual data here. Where is it? Where's the stinking data? Here it is. Boom. So here we have our Google Sheets data, and it's arranged by day, day 1, day 3, all the way till something like day 10 or 11, which is the last day that you collected data. And this is, it's not sorted in any nice clean way in the same way that all this data was all set up and sorted for you, because I picked out, inches. Maybe when I was collecting this data about CRH boys, it was not only height, but weight, maybe waist size, maybe ethnicity, a whole bunch of things, but I selected out inches from that entire data set. Similarly, perhaps Mr. D's ice cream sold was one of the pieces of data, but I could have had uh, maybe it was the number of cupcakes that were sold. Oh, hold on, you guys. My wife is going to ask me a question. Sorry about that interruption. Okay, so you understand that these data sets are trimmed already. They already have the information that I wanted to use to tell my point, whatever that story was that I wanted to try to convince you of. So when we then go to the data set that you guys collected, this has everything. All right, it's a big pile of data, and you don't yet know how you're going to use it. You don't yet know if there's even a trend that exists. Maybe the flower food is beneficial, maybe it's neutral, maybe it has a negative effect on the cut flowers. You don't know that yet until you start actually hammering away at the data to see what it reveals for you. So that's a very important part of this process. So the first thing that you already know at this point, but you don't know as of the moment when I was creating this screencast for you, is that you all know which letters received the flower food and which letters did not receive the flower food, only got water. That's going to help you to sort things out. And obviously, that's going to be the sort of first step in the process of determining what this data reveals to you, and then what data you're going to use to graph and help support your assertions. So, assuming that you have that information, the next step then is to select out which piece of data you're going to focus in on. It might be leaf count, it might be flower count, total petals, number, et cetera, et cetera. But keep in mind that we did this for day 1, day 2, all the way up to day 11 of data collection. So we don't have all the leaf counts together for A. We don't have them all together for B, for C, etc. And we have them all on different days. Now, you can do one of two things, right? You can choose to graph each day and look at the difference that exists from the very beginning and see a trend that exists over the course of time. This is similar to what we did over here when we looked at the wolf population, a time interval across the bottom, and then the change that exists on the y-axis. So you may choose to do that, and that's fine and all, except for the fact that you don't just have a single population here. You have a whole bunch of these things, a whole bunch of leaves from the two different groups. So you're going to have to combine those in some way. Perhaps you're going to do an average, maybe you'll do a sum. Some sort of way you're going to have to make sure that you create one statistic for each of those days per grouping, whether it's the experimental group or the control group. I leave that to you to figure out. Another approach you could have is, let's say that we go to day 11 and we are looking, no, actually, let's say we go to day 7 or something like that. And we look at the data, and what we can do then is compare the control and the experimental group data for day 7 and only day 7, not taking into account days 1, 2, 3, 4, 5, and 6, and also ignoring days 8, 9, 10, and 11. The reason why you'd want to do that is, imagine this for a moment. Imagine that instead of doing this experiment for the 2.5 weeks that we did it, instead we did it for an entire year. Well, at the end of day 365, I think you could very well imagine that both sets of plants, both groups of plants, would look pretty sorry. After 365 days, they're all going to look equally like a rotted mess of goo. So it doesn't really make sense to compare the two groups at that point, because it's so far out from the effectiveness, even if it were effective, of any sort of change, any sort of variable, in this case, the presence or the absence of the flower food. It would only make sense to see whether or not these things would sustain the life of the cut flowers. And so that's going to happen, say, around 2 weeks out after you purchase the flowers, not 365 days out. So the reason why it was important for us to collect all this data is in some ways we needed to figure out what that point was where the flowers that had the flower food remained looking okay, while those that didn't have the flower food clearly had a precipitous drop in the way they looked. I have no idea where that point's going to be. I don't know what day that is, especially since I'm sitting here doing this screencast when we've only collected 4 days worth of data. I don't know where that's going to land, but you have the perspective at this point of being able to look back at the data and seeing where that change is most apparent. That's going to be something that takes some time, and it requires a nuanced look at things. And it also is something that you're going to have to justify in the actual journal article write-up, why it is that you decided that, say, day 7 was the day that you wanted to use as the the day of comparison for the data. So it can become a pretty complex process. Keep that in your brain. And you might have to try a few sets of data and manipulate them in different ways before you find something that works for you. The other thing I want to make sure I impress upon you is that if you do decide to use a data set, you have to use the entirety of that particular data set. So for example, if you use flower count, you have to use all the plants for that flower count. You can't just use A, B, C, and then say, you know what, D doesn't help me in any sort of way, so I'm going to throw out the data for D, but I am going to use E. You can't do that. You can't be selective about the kind of data that you go for. You have to use it all. Otherwise, you're just basically fudging data when that happens. Now, that doesn't mean you're using every single piece of data. That's not what I'm saying. It's just that when you do start to use pieces of data, you can't throw away parts of a set of data. Okay, I hope I've made that clear because it is a little bit tricky. All right, crew. Well, I hope you learned from these 2 tutorials. I look forward to seeing you on Monday. It's been a while since I've seen you. Take care.